Good evening, everyone. We now move on to the second technical session of day 2 of the 6-day ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives. The second session focuses on a highly relevant and advanced topic, serverless computing, which has revolutionized application development by enabling scalable, cost-effective, and event-driven cloud solutions without the need for infrastructure management. It's my pleasure to introduce our second resource person for the day, Mr. Joby Joseph, Cloud Technology Head at TCS Cochin. So has extensive experience in cloud architecture and enterprise cloud solutions. His industry-driven perspective will offer valuable practical insights to all participants. Sir, we are truly honored to have you with us. I kindly invite you to take over the session and share your expertise on serverless computing. Thank you, and over to you, sir.
Yeah, thank you, Shani. So let me share my screen. Hope you're able to see my screen, right?
Yes, sir.
Okay. Yeah. Good afternoon, good evening, everyone. First of all, thanks for joining this session. It shows your interest and appetite to learn new technologies and the latest trends in the industry, right? So today we are going to cover more about the serverless computing. I know you are familiar with the cloud computing. Personally, I started from traditional IT infrastructure around 2.5 decades before in 2000, and then gradually shifted to cloud computing in 2013, 2014 time. Okay, then last 2 years I'm just transitioning to AI, right? Which is how to use cloud and AI together. That's what I am doing now. So if you see the last 3 decades in my career itself, so a lot of transition, right? Every 10 years there is a huge change in the technology is happening. Moving from traditional IT to cloud, and cloud to now AI, all this is happening. That is why this topic is related to that. And considering that AI has huge potential going forward, this whatever we are hearing today, the serverless computing is obviously very much useful for the AI use cases like AI inferencing and training, where we create AI models and then use the models for different areas, right? So what we are going to cover today is mainly, will be giving a brief overview about the serverless, and then what is the core concept like functional service, backend as a service, event-driven architecture, those kind of things, and also the key benefits and challenges. Why so serverless is not going to be applicable for all the use cases. There are certain use cases we have to use serverless, and so we'll go some kind of deep dive into two areas like AWS Lambda and Azure Functions. I think we don't have too much time to do the full demo, but I will show the console how this services will look like, and I have a very brief overview of that services. Then what are the best practices and design patterns we typically use serverless architecture in developing the applications, and then the future trends. That's what we typically are going to cover in the next 90 minutes time frame. Okay. So first of all, the first thing we have to consider a misconception that no serverless means there are no servers. Okay, so many people will talk about there are no servers, but that is not the truth, right? It is a big misnomer that serverless doesn't mean it is having no server, right? Actually, all these applications running on top of servers only. Only what difference is make is that how much management, infrastructure management that developer or architect has to do, right? Serverless means many of the actions required. When I worked with the IT infrastructure in the past, a lot of work as a system administrator we have to do, make it the environment ready for the developers and the application team, right? Setting up a data center, installing the servers, configuring the OS, all kind of things, right? We have to high availability, everything has to be taken care by ourselves. Okay, but serverless means there are servers, but maintaining that servers or the environment is taken care by the cloud provider or a provider, and developers can focus mainly on the application development and the business logic or business applications. So that is the key difference here. So don't consider that serverless means there are no servers. Servers are there, but the management of those areas are changed. So application they will more focusing on the application develop, whereas the cloud provider will focus more into the other aspects of scaling, security, and everything. The second part is more into the abstract infrastructure we talked about, right? So when we do a typical server management, in your environment also there are many Windows or Linux systems. The Windows systems need a lot of patching, right? Every month Microsoft releases patches, and then security updates. We need the scaling, right? Whenever the number of consumption is more, the load is more, we have to scale. That is capacity planning there. So all these aspects is taken care by the and abstracted from the developer, and it is taken care by the provider itself. That is why the abstraction of the infrastructure is a more uh, area. And then we talked about the cloud provider. So all the vendor, being it as Amazon or Microsoft or Google, they handle the operations for the provisioning the operating system, then maintaining the security, updating it, configuring the runtime. So everything is managed by the cloud provider. Okay, so our application team can straight away focus on the code development and code maintenance there. Okay, and then the fourth element is more into it is event driven execution. That means it is not traditionally what is happening whenever we set up an environment, right? Example like an ERP system like SAP and everything. I still remember one of the customer, we are doing the SAP implementation. So a lot of work has to be done to set up that environment, and this environment has to be, a server has to be up and running 24/7, right? It has to be like that. But that is a complex ERP application. But those kind of applications are not suitable for the serverless. It is event driven. That means whenever we are triggering some event, for example, you are uploading some image from your mobile, you take a selfie and then upload that image, and then image has to be resized or transformed, or do some kind of uh, thumbnail tagging. So those kind of actions, right? There is some event is happening, and based on the event, certain tasks to be executed, that we are calling the functions, and functions will be executed, and that will be tear down. That means we are completing within a short time, right? That is this kind of architecture is typically used for the microservices architecture, and that is a best suited candidates for the serverless. Then the fifth element is automated scaling. It's very much important, because whatever the new application coming up, you imagine a scenario, the Flipkart or Amazon, and there's come to Black Friday or some kind of promotional sales happening, right? So how much will be the volume? It will be, they handle 2 times or 3 times or even 10 times or 20 times of normal load. So traditionally, what we have to do, we have to provision the capacity and keep it idle, because we don't know how much load will come. But that is why it's very important to how the automated scaling. If it is only single request or 10,000 requests or 1 million requests coming, the application should be able to handle it. For that handling, we should have an automated scaling has to happen, right? Depending on the load coming in, it has to scale up and down. And if there is no load, it has to go down on minimum. That is why we can optimize the cost. That is again the last one, the paper execution or usage. This is the biggest advantage of cloud. Okay, so earlier we had to have a huge capex. We have to set up a data center and infrastructure. But when the cloud comes, it is a paper execution. Actually, serverless is the actual paper execution. That means if there is no load coming, it will, the consumption will be zero. You are paying $0 or ₹0, right? But if there is a consumption, you pay for it, and your consumption spikes is 100 times, 1,000 times, you pay for that, only for that particular duration. Even the serverless, you can go even millisecond kind of duration, and if you are consuming, then only you have to pay. That is the exact use of the pay-per use model, which is a core strength of the cloud computing. This is the some of the high level ideas or concept about the serverless. Moving on, before jumping into serverless, right, we have to understand also the history, right? We talked about the on-prem systems. We set up the data center and all the hardware, operating system and everything. The entire thing, we have full control. Everything we are managing, operating system, their environment, security, and application database, everything we are managing. Okay, so that is the on-prem, the earlier model. Then we got this cloud providers. If we take Amazon, they started in 2008, but by 2012 and everything, it was became a mainstream, right? The infrastructure service. You get your compute power, CPU and memory, those kind of things, and also you get a storage for storing, gigabits or petabytes of data, and also networking, how you're going to connect and handling the security like firewall. So all this things. So it's called infrastructure service. So the provider like Amazon started it earlier. Then Microsoft came with Azure Cloud. Then Google came with the Google Cloud Platform. Then Oracle. All club players came in picture now, right? Then another layer is the PaaS layer, where platform as a service, where is another layer of abstraction, right? You get a runtime. For example, you have to run in your application, you get a runtime with necessary libraries or to execute that application. So, for example, AWS Elastic Beanstalk, Azure App Service, or even Google had earlier one called Google App Engine, GEAE, right? So these are all PaaS platforms that providers brought in, where you can go and simply host your application without worried about the underlying OS or runtime there. Then we also see a lot of popularity on the containers. I think you might have heard about Docker containers, right? Many of the applications they use or containerized and using Docker as a container environment. So the advantage is that it is portable, right? We can move from one platform to another platform, or on-prem to cloud, or cloud to another provider, like that. So it is a portable and bringing a consistent environment, and also there is an orchestration. For example, the most popular orchestration nowadays is the Kubernetes. I think you might have heard about it. The Kubernetes is the container orchestration platform. So and all the cloud providers like Amazon, Google, or Microsoft, that has got a Kubernetes version. It's called as a Google Kubernetes Engine, Azure Kubernetes Service, Elastic Kubernetes Service from Amazon, like that, right? This is another layer of service called CAS, container as a service. You get a container to execute your application there, right? And the next evaluation is the functional service or a backend as a service. So where the developers can purely focus on the code or business logic, and the rest everything is managed by the provider like Amazon or Google or Microsoft. Then last one is SaaS model, right? The SaaS is where the end-to-end stack, even the application layer itself managed by the provider, and they are providing end-to-end stack. Okay, that's why you just manage your data. That's the model. So we more talk about the FAS and BAS today, the functional service and backend service. And then I think you might have seen this one. This is the typical definition of cloud computing and the National Institute of Standards Technology, right? NIST defined cloud and different service models. And then how it is differentiated. Whatever you talked about, inference service, platform service, or software service, the IaaS, PaaS, and SaaS model. So in which layer the provider is managing and you are managing. Whatever the blue color is the one where customer or the end user is managing. In on-prem, we have a full stack we are managing with a lot of operational overhead. Whereas if you go from left to right, many of the things is outsourced or given to the provider, like the cloud provider, Amazon or Microsoft or Google, and they are managing. And then you are managing only a small portion of this one. So if you take the serverless area, you can say it is some middle of platform and software. Predominantly it is a platform services, but we can say it is a little bit of higher enhanced version of PaaS there. It is considered as a FaaS and BaaS, functional service and backend as a service. So just to understand this one, so which layer our responsibility lies in. For a customer, we are more focusing on the applications and data side than the underlying layers, like the physical hardware or operating system or virtualization layer or middleware, runtime. All these are taken care by the provider, but the customer or the application team will be more focusing on the application and its application data. We are focusing on that, right? And the more and more we go for here, we say the left side we are get a higher cost and more control, whereas the go right side will get a lower cost but high agility, right? So the drawback is this model is that it will take a lot of time to set up this one, huge capex, huge time for setting up, To bring an application up and running, it will take months or even years to make it happen. But in this layer, if you move up, you are high agility, right? The more you can get the environment quickly, so that you can deploy your applications as soon as possible, which in turn will help the business to go to market, right? They can make their applications release to the market. Okay, so this is the abstraction layer. Now we come to the core layer of this serverless. There are two major components. So typically, serverless means most of the people will consider only function service. But in a serverless architecture, not only fast is coming in a picture, but also there is another layer called backend service, because the functions which is we have a piece of code and triggering the functions, which is execution runtime and scaling. All these are handled by the function service model, like AWS Lambda or Azure functions like that. But at the same time, when application cannot work in the, only for with that functions, right? But the functions has to have a integration with some backend services, like your database. You need to have a relational database to manage RDMS. Similarly, you need authentication system, right? How to authenticate the users and control the access. Storage, how to store the data. It can be, the huge file system or files or other data we have to store. Other APIs. So all these are backend services. So if you say serverless architecture means a combination of function as a service as well as the backend as a service. The FAS and BAS combined, we can say it is a serverless. Because many of the architecture, if you take, this will have a both layers coming up. Okay, the function service mainly it is executing the function. There will be a small discrete piece of code. It will be executed, and it is short lived. Okay, so we don't use these functions for long running applications, long running functions, right? And then triggered by events. We talked about it has to be, the execution will happen by an event, triggering by an event. So these are some of the examples we talked about: Lambda, Azure function, Google functions, all kind of things are examples of the function service. Whereas the backend service is um, more from providing the backend services. You be it as a managed services by the provider, but it is providing um, required services like databases. So, for example, S3 is a storage service from Amazon to keep the data there, subject storage. Like DynamoDB is a NoSQL database where you keep all the data, application data, API gateway, then authentication service. All these are the examples of the backend services, which is tightly integrated with your functional service, and all together this is called as a serverless architecture. Okay. Now coming to the execution model. Okay. So if you take a serverless execution, so what is typically happening? We talked about event driven, right? There's a event trigger. That means there's a source. It can be a mobile app or it can be another HTTP application. So a source or event is happening. This event can be anything, right? You are uploading a file to an S3 storage, right? You take a photo and upload the photo to an S3 bucket through your mobile app, right? Or it can be a database change or an HTTP request. All this can be a potential source of event. That event will be going through an API gateway, and then it is triggering a function. So your function that is nothing but a piece of code written in Java or Python or Node.js or any of the popular languages. It will be executed. Your environment is getting created to running your code, a Python code or a Node.js code, and then the environment is getting created to execute the code, and then you execute the function. Okay, and then by the time when you are creating the environment, there will be CPU allocation, memory allocation has to happen, right? You have a processing power and memory to execute that function, right? That is serverless platform, like example Lambda, right? So you execute the function, and then once the function is executed, for example, we uploading an image to an S3 bucket, and then the objective of that function is to create a thumbnail of the image. Assume that the application is a for a larger online bookstore, right? So then you have to add an catalog, then you add a image of the book, the cover page of the book, and then you have to create a thumbnail for that book. So that creation of the thumbnail is a function, right? So then you upload the image or a photo, then it is triggering the function, it is creating a thumbnail. Once the thumbnail is created, automatically whatever resources we provision, CPU, memory, everything will be terminated. It is not going to continue there. Next event happens, next image is uploaded, then you trigger the function again. So the advantage is also will be executing whenever we need it. This is on-demand execution or event-driven execution. Okay, and then um, we have a all the resources which is a provision, they will be deallocated. Okay, so the advantage is that we are paying only for the time we are executing the function. For example, a function took only 100 milliseconds to execute. I will be paying for only 100 milliseconds time. I will not be paying for a 24-hour window there, which is not normal for the other application, the IaaS model or something, where we have to pay for the compute and memory power that you buy, or even the environment that you get, right? You have to pay for whenever you are making that system up and running. But here it is purely the moment you execute, that particular duration is we are going to pay for it. Okay, that is the biggest advantage of this serverless execution model. So this is a typical example. So there's a trigger. Trigger is creating a function with the proper CPU and memory allocation, and then once the function is executed, it is tearing down the function and will be closing that one. It will be repeated for n number of times, and also the load is more. It can scale this. It can create n number of functions to scale the demand, maybe 1,000 or 10,000, whatever the limit, and then it can execute it. That is the execution model of we are saying. Okay, now coming to the advantage of serverless, right? So the number one advantage is the operational overhead, right? Reducing. If you want to take a traditionally, if you want to maintain your hardware, your operating system, or the runtime, a huge effort, right? You have to ensure that all the security updates patches are done with the provisioning activities, patching, scaling. It's very difficult. The scaling is very difficult, right? Because we need to plan accordingly how much capacity we are going to hit for the season. So that was the biggest headache in the past, right? And then and that is also creating a lot of idle resources. For example, if I am my capacity is for handling a peak workload demand for December, right, where the festive season is there, and a Black Friday in US, a huge rush will come. So but if your capacity is there for managing that one, then you are wasting that resources. The remaining period you are not using the capacity, right? That is one of the biggest advantage of this one. The operational overhead is reduced. You are not maintaining anything below OS or anything, that is taking a provider. The scalability we talked about, fluctuating workloads. If it is 100 times or 1,000 times, your application will be able to handle even 2 millions, right? So that is the power of this serverless architecture. It can scale very rapidly, and then if the demand is not there, it can come down to zero. That means that is bringing the cost efficiency, right? So only we are paying for actual compute time and resources needed. That again brings another aspect. We talked about faster time to market. Okay, nowadays every business, right, they want to release new applications, new services, capabilities to the market, right? And that is a competition, right? So if you are not bringing new capabilities to the market, you will lose the market share. So that's why. So and my majority of the time is going for one side is the application development cycle, and second one is your environment readiness cycle, right? How you are hosting the application. So and then serverless architecture is predominantly helping the second part, how to optimize the environment, how you can get the environment faster, right? Rather than waiting for a longer period of environment readiness time. I still remember the SAP implementation project we did for Kochi, that customer, right? It took almost 6 months to get the entire thing ready, starting from data center, right? So that is impacting the time to market for the customer. Now the other one is the developer productivity. It's very important because the developers, their focus is more into, they don't worry about the scaling, they don't worry about the environment the availability. They just need to focus on the application code, and then the code can scale automatically, or for the application can scale automatically, and they can focus or their core area. It is improving their productivity and their experience, right? Because they are getting the environment much faster time, and also they want to experiment. That's another important part. If you want to experiment something, so you can go take create some function and test it, and then you can tear down and we can do it. You are not paying for that. The other one is high availability. Assume that you have to set up a environment which is very highly available with a and maybe very few minutes of downtime required, right? Setting up that kind of high availability needs a lot of system configuration. Okay, the custom configuration, load balancing, a lot of things required in the high availability area, right? But here in the scenario of serverless, what is happening? All are managed by the cloud provider, because cloud providers, they have a different concept of regions across the globe. They maintain regions. Within each region, they have zones, availability zones, and this whatever functions we are running, the cloud provider is ensuring that it is spread across multiple regions or even multiple zones within a region. That ensuring that even if a one hardware failure or one server failure will not impact your application, so your application will be able to run from alternate sources. So that is the biggest advantage of serverless architecture, ensuring the high availability and fault tolerance. Then lastly, the environment benefits. Nowadays, everybody is talking about the AI, right? And one of the drawback of AI is that the power consumption, right? How much power they are consuming. Even TCS announced a new venture called Hypervolt. We are building AI data centers across India, right? So and because of the next 10 years, the demand for power is going to be high rocketed, right? And then that is one of the biggest challenge. So by adopting a serverless architecture, especially for the AI inferencing means you are creating an AI model, and as end user, you are consuming the model, right? You have to use the model for some prediction or some kind of recommendations. So you have to use that model. So AI inferencing, we can use serverless, and then because of it is mass efficient utilization is happening. We are not making this server up and running for 24/7. So and only the event driven or on demand execution, your resource utilization is very high, which in then reducing your energy consumption, and you are making more green, right? So that is very much important in future, because we have to go with the energy efficient sustainability is one of the key pillars of the best practices we have to adopt, right? This is one of the key advantages of serverless architecture. Now coming to the other side, right? Every technology has its own pitfalls or drawbacks. So some of the drawbacks, if this technology, one is the the cold starts. The cold start means we talked about the event-driven architecture. The once an event triggers, the environment has to be ready, right? So it is not readily available. Yeah, the Lambda function or a Google offshore function has to be, the environment has to be created, and then code has to be executed. There will be a delay or latency to start that a small container with your application code and the all runtime. So that will have, even though the delay will be in milliseconds. It is delay means not minutes or hours. It is only milliseconds delay. But even some of the applications, that delay can impact. Okay, and every time whenever we are executing a function, it has to create a new container with the required runtime and the application code and everything. And if the application code is bigger, your application has got a bigger code, means it will take more time to start, right? So that is called a cold start. So we have to ensure that there will be a cold start, means there is a latency for the initial functions, and then when the infrequently used functions, if the functions are used frequently, it can trigger concurrency. But if infrequently used functions, there will be a delay of starting the functions. The second disadvantage is the vendor locking. I still remember we developed one of the application, I think few years back, around 2020 time. We created AWS Lambda and DynamoDB, all kind of things we used, the FAS and DAS, the BAS architecture, right? So then there was a business situation that we have to move from AWS to Google Cloud, right? Because and even Azure also, to Azure. So the problem was that, and we had around 300 Lambda functions we written for that application, right? So we have to each and every lambda function has to be rewritten for Azure functions or even the Google functions. It was a complete rewriting of the application, right? So because the way the vendors are treating AWS or Azure, Google treating um, their functions is different. So whenever we are making a code or developing a code, and that is specific to there's some kind of tight coupling with the platform like AWS or Azure, and because of there's a lock-in, and if you want to move from one platform to another platform, it is requires a significant re-engineering exercise, which may take some kind of challenges. Okay, that is only if you are moving a platform. If today you are in AWS and tomorrow you want to move to Google or Azure, that's why it is a challenge. The other third element is the debugging and monitoring complexity. Traditionally, what is happening, if you are on-prem system or IaaS model, you have full control of the operating system, right? You get all the logs from the operating system, what is happening. I can do a troubleshooting. And I think 2 weeks before I was working with a customer where we are deploying a Google Cloud Run functions, and then that function has to talk to Salesforce CRM system, and then we have some connectivity issues, and a customer had got a lot of internet networking devices like firewall, those kind of systems, right? A complicated system network architecture, because it is a life science customer. There is a lot of security baked in, and it was very difficult because we don't know what is happening, and we have huge reliance on the hyperscaler, and also get a different, the codes, logs, and the data monitoring data, and troubleshooting is going to be very difficult. It is not easy like earlier. Earlier we get direct access to the console. We can log into the operating system and find out what is happening in the network level or the other level, in the platform level. But here, since it's abstracted from us, we don't see what is happening in the below, right? That is why we have a complete reliance, and we have to ensure that the debugging monitoring complexity is addressed through proper observability tools like there. Then fourth aspect is statelessness, right? Typically, this serverless architecture is intended for stateless applications. If the application needs to maintain a state or data, it has to be taken outside. That's what we have the BAS system, backend service, right, to maintain the moving the data to a database system or other thing. So it requires external storage to data persistence, because the functions cannot, because once the function executes, it tear down and it terminates. So it will not maintain any state or data there within that function, right, within that particular container. So that is why it's very important. If the application is stateful application, we have to think about how we can manage that, right? Then the other aspect is execution duration limits. Some of the when the providers, they also limit some limit. For example, a lambda function can execute for maximum 50 minutes, right? Maximum runtime limits. I think now AWS has increasing that limit, and their long running function is allowed now, but there are certain limitations there, and it is not intended for a large application, monolith application, which can execute for longer period, right? So there's a limitation there. And then other element is resource limits, like the duration limitation. There will be limitation for the memory and CPU, because you may get a maximum 4 GB memory or 2 GB memory kind of thing, and it's a very short-lived container. We will not get a very huge system like 16 GB or 30 GB kind of capacity, right? So that is not intended for this serverless architecture. So you have a resource limit, and your function should be executing within that limit, and then you go cover. Then another last concern is the security concerns. So even though we say it is managed by the provider, but we have a shared responsibility model, right? So we call it as a security in the cloud and security of the cloud, right? Security of the cloud means the hyperscaler, AWS, Azure, Google, they are taking care of all this patching, security, and everything. But in the cloud, if you are developing an application, serverless application, your code has to be secure. Okay, if there is your application code is not secure, then their system is gone, right? So still you have to where the infrastructure part security is taken care by the provider, but the code security is paramount, and the customer has to take care of that code security. This is one of the drawback of serverless. Okay, so we talked about the advantages and drawbacks. Now we see what are the different use cases where we can leverage this serverless computing, right? One example is your web application and APIs. So for your mobile app backends or RESTful API applications, a single page application, web application. These are all the typical candidate for the serverless application, right? So we data processing. So nowadays a lot of data has to be processed. You get the data and then you transform the data, and in the data pipeline is very important in many of the application, even the AI also, right? You have a data pipeline. So if you getting the data and then processing the data, those kind of areas also it can leverage this serverless functions. Then even different workflows. We talked about the image upload use case, right? When you're uploading an image, and then similarly IoT device is sending the data that has to be processed, and also file conversions. Yes, uploading one file to another version, another file format. So those are some of the examples of event-driven workflows where we can use serverless, and then chatbots and AI backends. So nowadays we are seeing a lot of AI agents and virtual assistants as a bots, right? And also AI backends. A lot of for models you have to it's called AI inferencing, right? How to use the model. So you are leveraging the model for predictions or recommendations. So if you are all these kind of use cases, we can use serverless to give real time and scalable services to the applications. Really a scheduled task. For example, if you want to do some kind of short term task. For example, you have to do a periodic report you have to generate. You have to run the backup. You take a backup every day, certain intervals. Then some clear up task. This can be scheduled, right? It is not a. It doesn't really require a long running batch job, but a small task. Those kind of things we can use the serverless architecture. Similarly, stream processing. Okay, so the data streams, right? The data, the Genesis or even Hub. So the data is coming from IoT devices, sensor data. It is coming, and we have to manage the process the data on a continuous basis, right? So this is one of the example of serverless. Then DevOps automation is more into automated deployments. You have to do the infrastructure management. You have to do the provisioning, all kind of things where we can use the functions to manage those activities, small tasks which is required for the DevOps pipeline or infrastructure code pipeline there. These are some of the real examples of serverless. Now we coming to this the serverless providers. We talked about the some of the providers like Lambda. Okay, and this Lambda is AWS is a pioneer in the cloud technology, right? So and they started with IaaS model in 2010 or 2012, that period. Then they started this Lambda functions long back, right? The AWS Lambda is a fast function service model or service from the provider, and it has got a rich integration, right? Because the backend services we talked about BAS, it can be a storage system, or it can be a database, a NoSQL database, or API gateway, queuing service, or streaming service. A lot of backend systems are integrated, and it can support many runtime. So you can write your application Node.js, Python, Java, C#, Go, Ruby. There are a lot of runtimes it supports, and also the tooling and community support is there, because Lambda is one of the most popular serverless technology we use there. Similarly, we take Azure Functions. So it's a Microsoft fast offering, Azure Function. So just got a deep integration with Azure services like storage, blob storage or Cosmos DB, even Hub, Logic Apps. These are all Azure native services which can support the Lambda as a backend. Then it also supports the different languages, right? Node.js, Python, like many languages, and also flexible costing plans. It just got a different consumption plans, a premium app service plan. There are many different models of consumptions available in the Azure Functions. And the last one is the Google Cloud Functions, where we have a Google. This is a service from the Google. So it is integrated with a Google services like Google Pops Up. I think there's a noise is coming. Somebody can mute it. It's better. Okay. So yeah. So Google services, it can storage, or Firebase is a mobile backend. Similarly, it supports different languages, Python, .NET, Java, all kind of things. And also bringing more developer experience and integration with the Google product ecosystem, right? This is the three examples of major serverless provider. AWS Lambda, Azure Functions, and Google Cloud Functions, right? Now coming to the, we'll show. I know we are talking about theory and everything, so it is coming to this example. You take one example how we can when you are developing or deploying a serverless application. So what are the steps required, right? So the scenario here is that, a very simple application, you create an API endpoint that returns hello serverless message. So when you are one a web browser or a mobile app, somebody is hitting an API endpoint and it is returning a message like a hello serverless, like a hello web application, typical web application, right? So so what is required? First step is that if you want to develop a serverless application, first is one is select the cloud provider and fast service. We talked about a different provider like AWS, Azure, and Google. Example, you take AWS Lambda as your execution environment, right? Then you have to define a trigger. So what is going to trigger this function? Whether it is a HTTP GET request coming through an API gateway, that can be an example of a trigger. The trigger definition is very important. Then you have the function as code. This is what exactly your piece of code is running. For example, if it is a very simple code, it is taking an example of, it is written Node.js language. So you can say it is handling, taking an event, and then once the event is received, it is executing the function. The function is a very simple function. It is creating a displaying a message like a hello from serverless Lambda. This message, right? That is a very simple function, right? So it is a getting an event and it is a triggering a function, and function is executed and it is displaying the output and giving the response back to the user and closing. That is closed. This is what this is a simple function we can write. And if you take the Azure functions, it is concept is same. So you have a you get a input trigger. There's an event is coming. Each HTTP request is coming inside, and then we define some parameters, and then you define output message. Output is again you send a response back to the user saying, okay, hello serverless is the message is passing the user. This is written in Python, right? So the concept is same. So everything, the process will be same. There should be a trigger, and there should be a output execution, and then you are providing output to the another system or the end user. This is what typically the serverless function. Then the other, once you define that one, okay, then you have to deploy that application or function into the environment, right? That is, you are say the conferring the function. When you are conferring the function, you have to say, okay, which runtime you have to use. We talked about the first example, we took the AWS Lambda. It is a Node.js runtime environment. Second example, it is a Python, right? In Azure functions, we Python. So you have to select the runtime, which runtime you are going to use. Then memory. So what memory you are going to allocate? Maybe 128 MB or 512 MB or 1 GB, 2 GB, those kind of, depending on the size of the function. Okay, so the area function we talked about is very small function. We need only 128 MB kind of memory is required for that, right? Then timeout you have to set maximum time what is allowed. 30 seconds can be a timeout. If there is no invocation after 30 seconds, it can be timeout. Then the permissions you have to set, right? So for this lambda function, it has to write to a storage, or it has to be write to a database system. So you have to give permission. Okay, this lambda function can connect to any other systems. For that, we have to provide the privileges. It's called IAM, right? Identity and access management permissions you have to give. So what other services this lambda, or what kind of task this lambda can execute or the function can execute. So that is the fourth step, right? Configure your functions, and then you deploy a code to the cloud provider, AWS Lambda. Then you can do the testing, right? You invoke. Either you can do a testing through the console and then through API endpoint. So this is the pictorial representation of that one. So you have a client is coming either through a browser or a mobile application. It is a triggering event is happening. So you get a get request is going to API gateway, and from there it is invoking a function. It can be a Lambda or Azure function. Once the function is executed, it is sending the response back to the API gateway with a message, right? The hello serverless, that message is returning, and the user is getting the this is very simple, right? But the typical serverless will be very complex application. It has a number of multiple invocations, multiple functions to be executed. That is what the overall architecture will be. But this is a very simple architecture there. So let me show you some of the examples. Otherwise, you may be can relate. Okay. So this is the platform. I don't know whether how many of you gone through the AWS platform. You can see this is the AWS platform. You can see all the services. And I have taken you can see all these are different services. So Lambda is coming typically under the compute services. You can see Lambda is there. There are a lot of services, right, for the platform. So we take a function. So this is what we talked about. I have already defined a function, a demo up here, and you can see uh, it is runtime is a Node.js. This is what we talked. Whenever you're creating a new function, if you go here, the first thing you have to give the runtime. You have to give a function name. You can see the runtime. Okay, this can be a .NET or Java or Python, Ruby, or kind of. You have to select the runtime. Which language you write, and you can use that one, right? Similarly, you have to. Uh, this is what I would say durable execution. Earlier there was a hard limit of 15 minutes, but you can also extend the limit. If you enable this one, your function can be run more than 15 minutes, right? Then architecture leave that one. So these are the you go create a sample function. If you take this function we created, you can see the code, right? The code, like the code we defined there, a sample code for creating a uh, that hello application, right? You can say a Node.js application. So if you see the code, you can see it is taking an input and sending an output, right? Output will be see hello from durable lambda. Like this message is going output, right? So like that. So you define the code here. You can what you can do. You can all the code, function code, you can write in your language, and you can make it a zip file, and then you can upload from the zip file to here, and then you can load it here. Or you can have a live editor, Visual Studio kind of code editor. You can use, and from there you can import it there, right? That's a way you can go. Similarly, if you see the other configurations, we talked about um, the examples, right? Let me check. Yeah, the general configurations we talked about. This is what you can see the timeout. So we can define the timeout whether it's 30 seconds or 1 minute. If the function is idle, if the system is not running, so how much you can this means this function will time out after 1 minute. If this is idle for 1 minute, it will be timeout. Clearly, this will be taking only 120 MB of memory, right? Then we can say it is storage is only 512 MB. Storage you can take from externally, like that. So now if you want to test it, so we have okay, this is a console. You can test it whether your function is working properly. Let me do a testing. It will show. You can see 1 second ago the execution is run. You can see the output, right? This is output coming here. So if you have a external facing application, you'll get you can through browser you can take it the application output and you'll get out. So this is the output is messaged here, right? This way is very simple. So you don't worry about configuring the underlying infrastructure, runtime, OS. Nothing is required. You just simply you upload your code and you define your application, and you can execute it there. Okay, so this is a example of AWS Lambda functions. We can define n number of Lambda functions there. Similarly, if you take a Azure, right? So the sorry, let me yeah, the Azure. This is the Azure similar to AWS. This also coming under the compute. Okay, if you take a compute services, um, Azure compute services, I can see a lot of compute services. You have VMs are there, virtual machine, which is a typical OS. So you get a Windows or Linux machines here, but that is not serverless. It's IaaS model, right? These are all IaaS services. You get a computer, virtual machines. You get other things here, right? But the PaaS services, you can say there are other areas like app services. We talked about the PaaS earlier, right? So these are all PaaS services from Azure. Then the other one is serverless and microservices. This is where our function is coming. So you can create a function app. So I already created a serverless application here. So here you can define. Okay, so you can see all the activities, right? This is a function app we define, and there's a code also here. Okay, this is the functions. Yeah. So see, you configure everything here, and you upload your code, and if you want to create a new functions, you can go and create. This is what we are talking about. Azure is providing different consumption models. You see, flash consumption. The advantage of is that it is scaled to 0. This means this can, if your application doesn't have any hit coming, any request coming up for a minute, right? So it can go to 0. That means you will not have 0 charge, 0 cost. But some of the other models like this premium, it will not scale to 0. We have to maintain minimum one instance you have to maintain. That means you are maintaining that instance all time, right? Then your cost will be higher side. Similarly, here the concurrent consumption, maximum scale of instances, you can go up to 1000. Okay, this you can go up to 100 like that, right? So these are different consumption models that Azure provides. Flexible consumption, premium or app service or container apps environment, and all kind of areas, the plans, right? Um, so we can say all this networking, all these are integrated. You can see, and then a dedicated compute and prevent cold start. The cold start we talked about, right? There is a delay, right? Whenever we trigger a function, the environment has to be up and running, right? So and cold start is one of the drawback of the serverless. So there is a milliseconds delay to get that instance up, right? So so here we can get a mitigation. You can say we can always ready concept is available. So we can ensure that pre-warming kind of things we can do. We say that one instance has to be or a few instances has to be up and running so that we can take the first load, right? So that we can avoid the latency. It's called pre-warming or a concurrent provisioning. Those kind of things we can manage it there. Okay. So now this is the Azure part coming under compute. Now if you take the other part, we talked about the Google. Google also we see there are n number of services there. You can go and check. As I mentioned, this is coming under the uh, compute services, right? 1 minute. Yeah, so here we talked about a compute. Again, this functions is coming under compute engine. Compute under compute. So there will be option for functions. Okay, cloud run functions. And this is what we are saying. So if we search here, you can find out. So you can see cloud run functions, right? So this is what we talk about. Now Google has also made this integrated with the cloud run. So you can see we have defined many of the functions here. This is one we are using for one of the applications. So we create our own functions. You can see how many functions we are running, right? This is one of the application we are executing, right? I'll show you the backend front end is like this. Let me open it. So this is the application, right? So you get a website and you can log in and this is an example of this application. The entire application is running here, but we have defined you can see here, right? So all the this is the actual application where we are doing. But what I'm saying, so for that application, we have all this. There are many functions we defined here. All these functions has got a certain code. Okay, so a piece of code will be there, and it will be so yes, find out now how it is running. All kind of things we can track it there, right? So this is the example of Google functions, right? So and we can define a number of functions. If you want to create you go and create a new cloud run function, and then you can use it here, right? Okay. So write a function. So we can go here and you can create a function name select a region. We talked about where we have to deploy this function, where in Europe or US or India, whatever, wherever location we have to do it, right? Then you have, then you will create a, once you deploy that function, you will get a endpoint URL. Using this URL, you can access that function outside. If it is a web application, you can access that from outside, right? And also we can define the runtime. Google also can see a lot of runtime is supported. .NET, Go, Java, Node.js, PHP, Python, Ruby, all are supported here, right? Okay, and then you can automatic scaling. You say, see here, see minimum 0, right? Maximum we can define. Maximum we can put 10,000 or 1,000. We can put that here. Okay, so that is the scaling functionality we talked about, and then how you manage the internal aggregate. So this is an example of some background noise is coming, so you can mute it. Yeah. Okay, so that's why you define a function, right? So when you define, and then we can upload we can trigger we can add the trigger. Trigger is coming from where? It is a queuing services or a storage trigger or any other trigger. We can define the trigger, right? When this function has to be executed, right? Okay, and also you can see the pricing. The pricing, you can see the first 180K vCPU seconds per month is free, right? Similarly, storage also, this also free, and after that we can get the price. So that means it is if your application using only that much of access, then you will get a free tier, right? Like that. That is the advantage of this one. It is a very pay as you go, true pay as you go model, where we can get this one, right? So this is the 3 different platforms we talked about. The example of the serverless architecture we define there. Okay. Now moving back. So now the some of the examples, right? So we'll take an example of see, this is an example. Whatever we talked earlier was a very small function to print a hello world kind of messaging, right? But actual application, as I mentioned, it has got a very complex structure, right? So for example, this is a mobile backend. So there's a mobile application, and you have to use this serverless as a mobile backend. Okay, you upload, user is uploading an image or something, and from there it can go, right? So here in the architecture, there will be an API gateway which is taking the request, the trigger from the mobile user or mobile app. Okay, and then you can see this is a lambda functions. So these are the 2 lambda functions which is triggering and getting executed, right? There are certain tasks to be executed for this application, and then the functions has to be. There are 2 things, right? We talked about some of things. It has to be integrated with the authentication system. AWS Cognito is a system which can support authentication, right? It can support with the Google Authenticator or other authenticator or AWS or Microsoft Authenticator, different third-party authenticator systems, or token services, or DynamoDB. It's another NoSQL database. It can be a S3 storage. It can be a Elastic Cache for a caching, in-memory caching, right? Or RDS is for the database, like a Postgres database or MySQL database, like that. So all these functions, it will be getting triggered, and it will be leveraging the backend services for the authentication and data store, and then it is providing the output back to the user or to the mobile app. This is one of the use case. If we take another use case, we talked about the S3 hosted website. You can also, it is a very static website. You can also host in S3. S3 is a AWS storage. So you can see Amazon S3 is a storage where you put your static website here. So I can from a browser I can access the static website, and also it is going to CloudFront, which is nothing but a layer for ensuring the scalability and security there. Okay, and then once you upload that some image or something, it can trigger a function. The lambda function will be executing the function, and will be leveraging the backend services for this one. The example you talked about, the creating a thumbnail or anything, right? When you upload something, and then you will get a function executed, and it will be triggering and getting executed and getting output back to the user, right? This is some of the examples of architecture we can leverage, serverless. Okay, so now moving on. See, all the we talked about serverless. There are a lot of advantages are there, but not all the applications are suitable for serverless, right? Some applications may be suitable. That is what we say. Which are the patterns or good practices where serverless is going to be highly useful? Okay, so one is that good practice. We are making very small or single purpose functions. It is a it will be a disaster if you are creating a very big function or multiple functions stitching together like a monolith, right? This serverless is not a function there. This serverless is more useful for a microservice architecture where we have a very small single purpose functions which can execute and and then clear it off, right? That is the number one principle, right? Then we talked about statelessness. Okay, so the functions cannot handle the state. If a function has to um, preserve the data or it has to talk to another function, it cannot do directly. So what it has to be leverage a backend as a service for state management. Using a database or a storage, we have to manage the state, right? That is the best practices there. The second one, asynchronous communication. So typically we don't allow a function to function communication. Typically, right? There will be typically we use a queues or a event buses for connecting two functions together. So one first function will be sending a message to the message queue, then the second function will be taking from there, right? That is a asynchronous communication architecture is as a best practices we have to use it in the serverless. And then more and more we talked about event driven architecture, right? And we have to configure the triggers and event sources so that we can make use of that microservices architecture. Then infrastructure code is another best practices. We have to use tools to set up configuring. I show you all this through console, right? Create a new function, setting up the configurations, setting up the runtime. All thing can be automated through infrastructure code. We can use Terraform or some kind of infrastructure code can be used, which is highly recommended. In the cloud world, everything is even infrastructure also written through code only. It's called infrastructure code, right? So provisioning and management of the infrastructure, it is handled through infrastructure code. Advantage is that we can reduce the errors, because if somebody is creating manually, there can be error. So infrastructure code means first you define the code, then somebody senior has to review the code, and then you can ensure that there is no error, or it is the code is right or not, right, or the configuration is right or not. Second thing, we can do a versioning. So suppose if tomorrow we want to maintain a different version, you can do a versioning, um, and also we can do scaling. So everything is possible through infrastructure code. So that is another best practices. Use infrastructure code to create the serverless resources. Then we talked about comprehensive logging and monitoring. It's very important. One of the pitfall of serverless is troubleshooting. Debugging is very complex. So we have to ensure that we are putting a lot of mechanisms to enable logging, monitoring, so that we can trace and where the issue is coming. Right? We can go to that lower level and we can find out and the root cause and resolve it. Otherwise, it is going to be a nightmare, right? Then a smart cold start mitigation. We talked about the cold start issue. So we have to have some kind of mechanism. Either you have to do a pre-warming, right? You keep some of the instances ready. Not the if an application needs 100 instances, we don't do 100 ready, but maybe a 10 container can be 10 functions can be made as ready, so that the first invocation comes, it can execute with the up and running, and further subsequent events it can execute from the other one. So that is why we can mitigate the cold start, the delay of starting a container or a runtime, that can be mitigated. These are some of the good practices or patterns where serverless is going to have better output, right? Or the application can give better output. Now the anti patterns where we should not use serverless here is, one is monolithic applications. If the application is very monolithic, having a lot of functions or logic written as a monolith, a very huge complex structure, it is not suitable for the microservices or serverless. Similarly, if the application needed direct database connections, long-lived connections, it is not recommended, because whenever a lambda function executes, I talked about, right, after the execution, lambda function will be the function will be decommissioned. That's what we putting a timeout there. After 1 minute or 30 seconds, if it is idle, it will be decommissioned. Whenever they decommission, the database connection will also go, right? So whenever what is happening, if it is a long-lived database connections are required, direct connections are required. Whenever a new lambda function is triggered, it has to establish a new database connection. That's going to be having a lot of trouble. Then you have to use a connection pooling or proxies to ensure that you have a mechanism to access the databases. Okay, that is the other ID pattern. Then complex internal state. It has to see how it can handling the failure and scaling retries, right? How the application should be having that mechanism to manage that failure area. Then overlays on cold starts. This here we should not have too much reliance on cold start, and we have to tolerate or mitigate this delay or latencies happening with the cold start. Okay, and then lack of error handling or retry logic. I talked about if you are not considering this one, it's going to be a nightmare, right? So if you error handling and retry logic has to be there, and we should be ensuring that if some of the things are not functioning, then we should be able to have mechanism to retry mechanisms to make it happen, right? These are the areas we consider when you are when you're building the serverless applications here. Now the other one we talked about serverless, one of the current technology within the cloud, one of the most prominent technology area. But then we see what is the future, right? So some of the trends coming up in the future, what we are also interacting with multiple enterprises across the globe. What we see is that customers are taking serverless one of their strategy. Okay, so nowadays, even though there is a lock-in, but customers are going with the serverless because number one reason, the agility, right? It dramatically reduces the time required for you are launching your application, a new business functionality or new application, new capability that business can launch. Because of that, now we see a lot of enterprises are moving with serverless as one of the strategy adopting, and also we see other edge computing integration. Edge cloud is also another key area is emerging, especially AI and the data, where we need to handle a large volume of data and live streaming, where everything moving to cloud is going to be not practical, right? Then the edge computing is getting momentum now. So then they're also executing those functions at the edge side, Lambda at edge or Azure functions at IoT edge. These are all use cases coming, how we can use the serverless in the edge side, right? Then we talked about enterprise adoption. It's more robust tooling, compliance, and hybrid capabilities is coming up. Because of that, most of the enterprises are okay to adopt now. Earlier, there was some concern about serverless because of security and other areas, the observability areas. But now that is changed, and most of the enterprises are moving towards the serverless in the future. So the other trend is coming up. We talked about one of the drawback is vendor lock-in, right? So if it is AWS, Azure, or Google, a lot of lock-in is there, and the application has to be rewritten if you are moving from one platform to another platform. To mitigate that part, I think we see a trend of open source serverless platforms coming up, like OpenFast or Knative. These are all providing an option to make it as a platform agnostic. So you can deploy this on top of AWS, Azure, or Google, and then it is abstracting the native integration so that we can move from one provider to another provider. Similar like a container, right? You can use if it is a containerized application, we can move. Portability is one of the key feature. Like that, serverless also new emerging areas are coming up for the open source alternatives are there for the hyperscaler native services. Then advanced orchestration and workflow engines are there. That is also emerging now, because managing thousands or hundreds of thousands of functions is going to be a tedious job. To make it happen, there are even providers also coming up with a function like step functions from AWS, Azure Logic Apps. These are all mechanisms to orchestrate and manage the workflow. If there are hundreds or thousands of functions are there, how we are managing that in a orchestrating it in a better way. That is also emerging. Now the third, another one is the serverless containers. I talked about this one, the Google Cloud Run application. Whatever I show in the Google side, it is a Cloud Run functions. So now the hyperscalers are also bringing this kind of capabilities like AWS Fargate, Azure Container Apps, Google Cloud Run functions, and the difference between the fast and pass is blurring now, right? So they are mixing these two together, container service and platform service and fast. That distinction is coming down now. Okay, and also the other one, wider language and runtime support. So when we started the Lambda and everything, it was only very few limited support, maybe only 3 or 4 languages supporting at that point. Okay, but now we take, there are 10 or 12, 20 languages supported, right? That is keep on increasing. More languages, more runtimes is supported. There is going to be a give better flexibility for the developers. Then the other aspect is observability. Okay, because um, uh, nowadays without any application cannot go live without much observability areas like tracing, debugging, monitoring, all kind of areas very important, right? Because we have to troubleshoot the application. If the application is not performing, some performance issues or some uptime issues, then you have to find out what is the real root cause, right? For that we need enhanced tracing, logging, and debugging and everything. That is why now see a lot of even Google, Azure, and AWS, they are putting their native observability mechanisms so that they can monitor the serverless application also in a better way. So this is some of the trends we see there. Future predictions. It is going to be a big boom, especially considering the AI inferencing and everything. It is going to be one of the big area for future. So with that, so let me conclude here. I think I know it is a more talked about the um, theory part. It is a boring. It's talking 1 hour, more than 1 hour with the all theory. But if it is time for your questions, we'll take next. So almost 20:42 now. Another 15 minutes we can use for the questions. If you have anything. So over to you. Yeah. And this is some of the if you want to understand more about the serverless, there are certain learning available. You just Google it with the Lambda developer guide or Azure function documentation or Google Cloud function documentation. And also there's a good book if it is a by Dana Fincher called serverless mindset. That means whenever you develop an application, there should be a mindset to make it as serverless, right? Or a microservice based or serverless. So these are some of the good read if you want to know more about any of this topic. And also there are certain meetups. So even AWS and Google or Azure, Microsoft, they are also conducting meetups, right? Even depending on your city. There are a lot of meetups happening, and some of the topics that I select is serverless. Nowadays, most of the meetups, AI is one of the major area, but you see normal areas like serverless or also happening there. So that's also one of the another source you can get more insight about serverless. They may have hands-on with a half-day workshop or full-day workshop kind of model, right? That's another source of information you can get it. So with that, I will hand over to you for questions there.
Dear participants, if you have any more queries, you can post it in the chat box.
I don't see the chat. Okay, let me.
I think there are no more queries. Thank you, sir, for the valuable and informative session. It was indeed an honor to have you with us. Thank you so much, sir.
Yeah, thank you, Shani.
Dear participants, the feedback link is being posted in your WhatsApp group. It will be active for 30 minutes. Kindly fill in. We'll be having another interesting and insightful session tomorrow at 6 p.m., starting our next session at 6 p.m. tomorrow. Thank you so much, everyone.
Okay. Thank you, everyone.
Thank you, sir. Thank you so much.